I'm going to present our topic called lane detection. This is our content. More and more driver assistance technologies are being developed to assure the safe road conditions since most of the accidents are caused by drivers first. It is important to detect curve lane because there are so many curves on urban area and by detecting curves, we can predict the direction of the upcoming road. There were several researches of the same matter. Some can detect various types of curves, but requires heavy computation, and others can detect many curves in real time, but only those which have more curvature. We decided to develop this algorithm since it is one of the latest researches and it functions in real time. We simplified some of the processes of previous research while maintaining the performance. This is our proposed algorithm composed of pre-processing, curve detection, and post-processing. First step of the algorithm to remove the perspective effect from the image. By obtaining homography matrix, we can apply inverse perspective mapping to the image. IPM makes lane vertically parallel as it is in real world. From this finalized image, we want only the lane information. For this process, we use assumptions on lane. Lanes are vertically parallel, lanes have fixed width, and it has higher intensity level than other area. We took 2 times 5 corner. The middle three represent lane, and each end represents load. By cross-correlation the kernel to the image and thresholding at certain value, we could have obtained only the bright vertical lines which are assumed to be lanes in the IPM image. Next, we fit a curve to thresholded image. Even though most of pixel values are assumed to be that of lane, there always is outliers which is non-lane information. Therefore, we use lens spline fitting instead of least square method in order to reduce the effect of outliers. Applying lens starts from getting random samples. With them, we fit a curve and score it. We repeat the process 10 times and got the one with best score as a result. By Renset process, we can fit a curve with the least effect of outliers. This is how to score each curve in Renset process. Previous research used length and angle information to score curves. The long straight line gets the highest score. It not only gives the best score to the straight line, but has higher calculation load. We instead draw horizontal line from each sample and counted the one that intersects with fixed curve. Because if the curve goes through or near the sample, horizontal line will have to intersect with curve. Lancet also have drawback. Since fit curve from randomly selected sample, it oftentimes does not cover all lane. Therefore, we perform post-processing. We draw normal line from the bottom end of curve to the bottom of the image. And we connected line if normal line intersects with lane information in binary image. And now we have robustly fitted curve on image. This is how we perform the experiment. For strict lane detection, vanishing point can be used to check the accuracy of the algorithm. However, checking accuracy for curved lane was not easy, since the curvature of each road is unknown. Therefore, we defined errors in 4 different types. negative first, positive first, post-processing failure, and balancing point disturbance by other vehicles. And according to these criteria, we checked every single frame manually. We ran an algorithm on 1.7 GHz processor with 640 times 480 pixel size source images, processing about 1,400 image results in average 35 frames per second with 91% accuracy. The accuracy seems to be low since we were strict on accuracy tests. For example, in these extension failure images, lanes were detected but just not able to extend it. And also, in case of missing one lane, we can copy the detected lane data to the other side, since width of the load is fixed and known. We developed an algorithm which can detect the curved lane and predict upcoming load conditions, and we have checked that it is a real-time applicable algorithm. However, our algorithm shows weakness when there is a white vehicle, inclined or declined load, strict lighting, big curvature, or lane with different width. And also for the future work, it should be tested on various load conditions since we only tested on sunny days. It should be more robust against strict linings and lane with big curvature. This is the end of the presentation, and we have a short video clip of the experimental result. This white line shows the center of the vehicle. This arrow always stays in the middle of the load and indicates the upcoming curve. This number shows how much the vehicle is off the center. When there is a white vehicle near vanishing point, our algorithm shows instability. And when there is a straight line, it also shows instability. Thank you for listening.